All right, class, this is the second of two videos from 9.5 that covers the topic of exponential and log functions. Last video in part one, we talked about the definition of a log, saying that if I have some value, it's equal to the log base b of x, then that is the same thing in exponential form, that the base raised to the y is x. Okay, so when we are asked to find the value of a log expression, notice that these are not equations. It doesn't say equals something. But this is exactly what it's asking. To find the value of this log expression, it's saying, basically we want to ask ourselves, what power of b is x? Or in other words, the base to what power equals this? Because that will tell us the value of this expression. So 2 to what power is 1 over 32? Well, for it to be downstairs, it would have to be a negative power, and we would be doing 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the value then of this log expression is negative 5, because 2 to the negative 5 is 132. Or in other words, we're just identifying what the value or the exponent here would be that would make this true. This base is raised to what power to make it 1 over 32. So asking the same question here, the base of 3/4 is raised to what power to make it, or is, or equal to make it equal to 9/16. So what would I have to do to 3/4, or what power would I raise it to make it 9/16? Well, if I squared this, 3 times 2 is 9, and 4 times 4, 3 times 3 is 9, and 4 times 4 is 16. So the answer here is 2. Okay, what is the value of this log expression? Again, I'm going to take the base of 49 and say, what is the power that would make it 7? So what would I have to raise this 49 to make it 7? Well, if I took the square root of 49, I would get 7. And remember that the square root of 49 is the same thing as saying 49 to the 1/2 power would be equal to 7. So my answer here, the value of this log is 1/2. Log base 6, 6 to what power is 216? Well, 6 times 6 is 36. Times that by 6 is 216. So this would be cubed. So my answer here would be 3. Usually I make all sorts of poop jokes and stuff about logs, but since I'm being recorded and I don't know who's gonna watch this, I'm gonna behave myself for this recording. All right, so that is how we find the value of a log expression. I'm just gonna have to keep pulling myself together here. The next thing that we're gonna want to do here is we are going to want to solve a log equation. So what would this look like? We want to solve a log equation. Well, obviously there's going to be some unknown variable. And always when we solve, or quantity, always when we solve an equation, we're looking for the value of the variable that would make the statement true. So here's my equation, and the thing I don't know is the value of x. What would I have to substitute for x to make this statement true? Well, the easiest way to figure this out is to put it in exponent form and say 3 to the 4th is x. Okay, well, 3 times 3 times 3 times 3 is 81. So the value for x here is 81. Okay, so when I'm going to solve, I just want to put it in exponent form and solve from there. So if I have, and it's the base I don't know, so log base x to the 49 is 2. Okay, so again, I'm just going to switch these two and put it in exponential form and say x squared is 49. And take the square root of both sides to find out what x is, and x is equal to 7. Something important to note here is that typically we would say it's positive and negative 7, but here, because we have to have a base greater than 0, okay, by definition a log has to have a base greater than 0, then we cannot include the negative value. So remember, there's no negatives, okay, for our bases. So x in this case is just 7. And it's true that 7 squared is 49. So let's look at a couple more here. Let's do log 4 to the 64 is equal to x. So again, this is going to be like your best friend right here, just memorizing that you're going to keep the base the same and switch x and y. So 4 to the x is equal to 64. And the way that we're going to solve this is we're going to use that rule that if I have a base and it's raised to a power, and I can get the same base and raise that to a power, then x equals y. So right now I want to say, hey, can I make this a base of 4? And if I can, this would be 4 cubed. And when I have the same bases, then the exponents equal one another. So x is going to be equal to 3 in this case. And it is true that 4 to the 3rd power is 64. All right, let's do 3 more of these just for the practice. I'm going to solve. Let's do log 5, 125 equals x. Again, my strategy here for solving is that I'm going to take it from log form and put it in exponential form. So I'm going to say 5 to the x is equal to 1 over 125. And I am going to do the same thing that we did right here. I'm going to say, can I make this base? Remember that 125 is 5 times 5 times 5, so it's 1 over 5 cubed. And if I can write this so that they have the same base, right, using the rules of exponents, that anything to the negative power is the same as 1 over that, right, using this rule of exponents, my negative exponent rule, I can put that 5 upstairs and say it's to the negative 3rd power. And when I have the same bases, then the exponents equal one another. So in this case, x is negative 3. And it is true that 5 to the negative 3 is 125. So we can verify those answers. So let's do 2 more of these. Let's do a log to the 2/3 x is 3. Okay, again, so what is this asking? Well, this is saying that 2/3 raised to the 3rd power is equivalent to the value of x. Remember, the base stays the same and I'm just switching x and y. Well, 2/3 cubed is 2 times 2 times 2 on top, which is 8, over 3 times 3 times 3 on bottom, which is 27. So the value for x here is 8/27. All right, last one here. Log x to the 1/8 is equal to 1/2. Okay, again, by rewriting this in exponential form, I can make more sense of this. Remember that to the 1/2 power is the same thing as saying the square root of x. But I don't want to know the square root of x, I want to know x. So I'm going to do my nifty trick here of raising both sides to the power of 2. And when I do that, I get then that x is equal to 1/64th. And that is the value of x. So this section kind of combines all the exponent rules and rules that you know, but especially this here is what you need to memorize and know. And for sure we'll see something that has to do with this or use this on the final.